Hi everyone. Through this class, we are going to study about the construction and working of helium neon laser. Ali Jawan and his co-workers in Bell Telephone Laboratories in USA fabricated the first gas laser in 1961. It is a 4-level laser system. So, here we get continuous laser output. In this laser, a mixture of helium and neon was taken as the laser medium and electric discharge was used for pumping. The helium neon laser consists of a long and narrow discharge tube of length 80 cm and diameter 1 cm. The tube is filled with a mixture of helium and neon in the ratio 10:1. The gas mixture of helium and neon forms lasing medium, and this mixture is enclosed between a set of parallel mirrors forming an optical resonant cavity. The mirror M1 is completely reflecting and mirror M2 is partially reflecting. The laser beam emerges through the mirror M2. The electrodes E attached to the discharge tube are connected to a high voltage power supply. When the power is switched on, discharge takes place inside the tube. The electrons and ions are produced in the process of discharge. Since the gas mixture is mostly helium, the probability of collision of electrons with helium is more. When energetic electrons collide with the helium ions in the lower energy level F1, they are excited into upper energy levels F2 and F3. The energy levels F2 and F3, they are metastable states. Hence, they can stay here for long time. In helium neon laser, the neon atoms are active centers and the helium atoms are the hosts. The energy levels of neon are E1, E2, E3, E4, E5 and E6. F2 and F3 are very close to this E4 and E6 energy levels of this neon. In gas, we know that atoms are always in random motion. During their motion, helium ions in higher energy level F2 and F3 collide with neon atoms in E1 level. During this collision, helium ions can transfer their extra energy to these neon ions. As a result, neon ions are excited into energy levels E4 and E6. This E4 and E6 level of this neon are metastable states. This helps to create a state of population inversion between E6 and E5, E6 and E3, and E4 and this E3. A spontaneously emitted photon can trigger laser emission. A light or photons emitted will move back and forth between two mirrors until it stimulates other excited neons and causes them to emit light. Consequently, 3 laser transitions takes place corresponding to the transition from E6 to E5. Wavelength emitted is 3.39 micrometer. Transition from E6 to E3, wavelength emitted is 6328 angstrom unit. Transition from E4 to E3, wavelength emitted is 1.15 micrometer. Here, this 3.39 micrometer and 1.15 micrometer are in infrared region. And this third one, that is 6328 angstrom unit radiation, that is in visible region with red color. The neon atoms in energy level E3 decay rapidly to this E2, which is however not a ground state. The E2 to E1 transition can be induced by collision of atoms with the walls of the discharge tube. To enhance the probability of atomic collisions with the walls, this discharge tube is made as narrow as possible. For specific selection of frequency, resonator mirrors are coated with multi-layer dielectric, which are highly reflective at 6328 angstrom unit and absorptive at the other two wavelengths. The typical power output of helium neon lasers lie between 1 and 50 milliwatts. Next, the advantages of this helium neon laser. The gas lasers are more directional and more monochromatic compared to that of solid state lasers. And these gas lasers can supply continuous laser beam without the need for elaborate cooling arrangement. And laser light emitted in this helium neon laser is in visible region. Here we get the red light out of this. And the stability is very high and cost is low. One main disadvantage of gas lasers is that the mirrors are usually eroded by the gas discharge and have to be replaced. Then the efficiency low and gain is also low. Due to this, helium neon lasers are limited to low power tasks. Helium neon lasers are used in industries, scientific instruments, and in college laboratories.